Hello and welcome to another episode of AI Security Ops with Black Hills Information Security. With me are my normal illustrious hosts. We have Bronwyn Aker, we have Dr. Brian Furman, and we have Mr. Derek Banks, and of course me. So welcome aboard. This episode is brought to you by Black Hills Information Security. If you have a need for an AI security assessment in some sort of deployment that you are about to consider and you haven't put us in your security development lifecycle, well, think about it. Consider us. Go hit the blackhillsinfosec.com website and find the Contact Us button. We would be happy to have a conversation with you. Today's episode is about data poisoning. So let's kick it off with a simple question, according to my illustrious friend, Dr. Furman. What happens when your data lies to you? Oh my God, that lying data, the essence of data poisoning. Well, let's talk about that, everybody. What happens when your data lies to you? Let's do some definitional stuff. I think I'll kick this to our illustrious Mr. Furman, or Dr. Furman, should I say. Go ahead, Brian.
Yeah, certainly. So when we're talking about data poisoning, what we're really talking about is kind of corrupting the data that is used for training or kind of fine-tuning or reinforcing the model, whatever that model might be. Note that this isn't just, we're not just talking about LLMs here. Data poisoning certainly goes back long before LLMs to classifier models. And so what we'll be covering today is going to be both traditional classifier models as well as LLMs, before getting into kind of what are the realistic threats and what you can do about it. But overall, just understand that with these data poisoning attacks, what we're kind of talking about is targeting the data pipeline in one way, shape, or form, and the integrity of that data so that we're disrupting it so that the models essentially behave in a way that's unexpected or undesirable.
Or I like to say suboptimal. What a lot of people don't realize is that an enormous part of developing artificial intelligence models, be they classification models or whatever they are, or natural language processing models, an enormous part of that is all in the data preparation. And this is this giant thing that's kind of unseen, and there's lots of data scientists working on it, and it is a very big, hefty lift part of the AI model process, even before we start training models, just prepping the data. And I think part of this conversation, if you don't mind me taking a little segue, is that our data scientists are not really well trained in cybersecurity or information security in general, and so they're trying to get their job done, just like software developers are trying to get their job done. And their goal is not really to look at the cybersecurity aspects. And so data poisoning can be an artifact that creeps in there with information security vulnerabilities, but also just with, poor data overall, right? So let's kind of talk about poisoning traditional classifiers and what that actually means. And we did mention classifier models. So maybe a little bit of definition, and I'm going to sort of go around the circuit here. Maybe Derek, if you can talk to us a little bit about what a classifier is and then what it means to poison data when you're dealing with a classifier model.
So, yeah, traditionally a classifier is going to be some kind of, machine learning model that its sole purpose is to determine if one thing is in a certain class of objects or in another class of objects. And so probably the best information security example of that's a binary classification problem of spam versus not spam, or phishing versus not phishing messages. And so, the algorithm that's used in the machine learning method is a natural language processing model in that case, and it would take in the text, convert it into vectors, and then determine whether or not it matched what it considered to be likely phishing or not phishing. And so the way you train that kind of model is you take a whole bunch of known phishing messages or labeled data, and then regular messages. And it's one of those things where I'll segue a bit. I really wish they had used a different word than training, because it means something completely different in other circumstances. And I catch people even earlier today, we'll train the LLM to do this. Well, that's not how this works. I really think it's an unfortunate choice of words. I wish they would have used something else, but here we are. And so the model is trained that when it takes in unseen data, in this case, an email message, it'll give a likelihood of whether or not it's phishing versus not phishing. And that likelihood is typically represented as a ratio. And so what does it mean to poison that? That would mean that I would have to have access to the training data, and then I would inject, known phishing messages that would be labeled benign, right? And then I would poison that data set. Now, how I got access to that data set is a completely different topic, right? But I was thinking through this before this episode. I mean, if we were going to start training a phishing classifier, we'd probably go get public data sets. And so that would be probably a whole lot easier way to poison the data, rather than getting access to my training data repository. And, I'll agree with you. And I don't think it's just data scientists. I think it's just, people in general are not as interested in information security as the members of this podcast, right? But I mean, I think that like everybody in IT or in some kind of technology role, people just want to get their job done, right? And so I think that's where you end up with, and now with, the hype cycle that we're in, yeah, data scientists might take a bad rap of having lax security policies, but I mean, it ain't just them.
No, it's absolutely not. So a couple of things that you alluded to. One was injecting new data with inadvertently swapped labels. The labels are essentially the pre-classification that exists on that training data that's going to be used to train the model. And yes, that would be bad. And another alternative of that is gaining access to existing data that's intended to be used to train the model. And let's say taking 50% of that set and just flipping the label to benign from, phishing, for example. And
I guess another thing I wondered is, could you muddy the water so much with malware where you were able to make benign looking malware that really didn't do bad stuff and somehow get that into the telemetry of something like Defender or something? I mean,
exactly.
It's possible,
and how much I love benign looking malware.
I mean, it would have to be, done in such a way where the classifier thinks that it's malware, but it's really not. So then you could somehow craft your actual malware, because the real goal would be to bypass it, right? Seems like such a convoluted way to get to the goal. It would be easier probably just to steal somebody's password.
Yeah. So one of the things I really love and don't love at the same time is this it's Hugging Face. Let's just go right to it, right? Hugging Face, it is Bronwyn decided to do a mic drop and leave the set. Hugging Face is one of these things, and Bronwyn returns.
I just had to close the door. There was
my ADD brain will actually get on topic here in a minute. Hugging Face is one of these things that has been a fantastic asset to the data science community, right? It's a very open source, collaborative platform. From a cybersecurity practitioner perspective, Hugging Face scares the living crap out of me, right? And the reason is all centered around the things we're talking about right now. Somebody will go out there and say, hey, this is a fantastic, highly authoritative data set on phishing. Well, how do you know, right? Is there somebody that's measuring that, right? I mean, I don't know. Bronwyn, what do you think?
I think that your terror is well justified. So I can't remember exactly which newsletter it was in, because I have like 5 or 8 of them all related to AI. And they were talking about how much, or rather how little data it takes to poison a model. Now remember, most models are trained on billions of parameters, and they will have once it's already been processed, pre-trained, all that, it still is gigabytes big, but it takes like less than 10,000 data points, I think, is the number that I recall, to poison a data set for use in some sort of AI, LLM, or whatever.
So I think what you're saying is to introduce just enough uncertainty in the neural network, essentially, when it gets down to inference time, and most models are neural
I think
network
that
based.
it's probably some percentage of your entire population of data, right?
Actually,
that would be what I would think, because outliers would really make some issues in some circumstances.
I would have thought so too. I will have to find that article and send the link to you folks, because it was surprising, and it was. The article said that it wasn't a percentage. It was like there was a threshold. And like I said, I've got to find it and forward it to you. But getting back to the key thing, Hugging Face is wonderful because it allows the open source community to contribute so much in this new field. And we know, because we live in the real world, that not everybody who contributes to these repositories has the best of intentions in mind. So it is very much a case of downloader beware.
Yeah. By the way, I just want, Derek has a pet peeve on the word training, and he's right to have that pet peeve. My pet peeve is calling Hugging Face anything to do with open source, because open source traditionally refers to source code. Published models and published data sets are not source code. So
I think that those kinds, like Hugging Faces, probably is it any different than GitHub or Docker repository or PyPy or any of those things where I don't think so, right? I mean, it's just that, AI is hot, right? I mean, I've definitely read news articles where AI GitHub projects have been attacked. Like somebody's, contributed some source code, then all of a sudden they're like putting a back door in, kind of thing, right? So I almost feel like it's not necessarily like Hugging Face or GitHub or PyPy or whatever. It's the developers that they're after, right? Malicious.
Yeah, it's those humans that are doing this stuff. Yeah, exactly right. So that actually brings me to a bit of a segue, because I think Bronwyn's article was likely referring to, and she can clarify when she finds it, but was likely referring to the current world we live in, which is very much dominated by natural language processing and large language models, right? As we know, which, I think I Twitter posted yesterday where I said, just because you have an LLM doesn't mean everything's a nail, right? But that's the latest trend, right? We got a big hammer, and everybody wants to apply it to all the nails around them.
Gives me flashbacks of Brian Fairman at DerbyCon in 2016. I'm just saying.
Yeah, right.
Poor vendor.
So, Brian made a statement here, which I'd like him to clarify for us. He says, with LLMs, poisoning gets a new twist. You don't need access to the training pipeline. You just need to influence what the model reads. Although, if your goal is malicious, access to the training pipeline would be awfully nice. But clarify that for us, Brian. What are you trying to get at there?
I think it's a bit of a little bit of a misnomer, and full disclosure here, I didn't put these things in verbatim, we'll say, but I think that what it's getting at is that there are different ways that you can influence the future behavior of a model without having direct access to the training data set, like per se, using things like taking advantage through the features such as reinforcement, human in the loop feedback, which is where if you are interacting with a model and it asks you, which answer do you like more, this one or this one? Or how would you rate this answer? 1 to 10, thumbs up, thumbs down. And you could maliciously give feedback to that, right? Like it could give you a correct answer and you could say, no, this is incorrect. And you can try to steer it towards like what you would like it to say in a particular case, and keep giving it that feedback that may eventually get absorbed into their fine tuning cycle when they go to update their model on the next iteration. I mean, how much feedback it's actually going to take to move that needle, hard to say. But I mean, that is one way that you could potentially influence it. The other ways, though, it's again, it's more of just how you're adding data to the training set without necessarily accessing or modifying the integrity of the data in the original set, such as hosting content out there that gets scraped up, that's going to
Yeah, that's what I was going to
skew.
say.
Yeah. Yeah,
Scrape.
Well,
exactly.
I love your second point that you have in our notes, actually. And then the second point, and the first one's absolutely relevant because human reinforcement learning is a part of a training cycle with LLMs, right? And they are doing that mostly to implement additional quality control and guardrails. And so if you were a malicious human, you could absolutely answer the question wrong and influence that training cycle. But the second one I kind of love because I got involved in supervised fine tuning for a while, and I backed off more on the recent history. But the idea of sneaking bad samples into domain knowledge specific fine tuning sets. So you know what our listeners may not know is that when you first birth a large language model, it actually doesn't know how to have a chat conversation with you, right? It's just a fancy token generator, and we've talked about this before. And so you actually have to go through a process of fine-tuning to make it understand the idea of, question response or instruct response. And this is called fine-tuning. And fine-tuning is often referred to as sort of enculturating the model. And it's a separate process, and it involves usually question-answer data sets. The question-answer data sets don't necessarily impact the actual data contained therein within the model, but they do impact the kind of cultural behavior of the model, is the way I like to think of it. And so, yeah, that could be really, really bad if you were to enculturate the model in a bad way. It's kind of like taking kids to school and teaching them the wrong things almost.
I was just thinking, I wonder if it would be possible if you could identify, like, just say for sake of argument that you knew the scraper had a certain user agent string, and when it hit your site, you could send it to a different part of your site that was like a LLM honeypot of poison data.
Wow.
So that sounds kind of fun.
Oh yeah.
If I wrote a scraper, it would use random Firefox and Chrome
love it.
user agents, but I wonder what user agents are used. So.
These wonder what statements is what makes this podcast so interesting, right?
wonder.
So it's you heard it here first time, breaking news right there from Derek Banks. Talk about RAG. I'll let Brian do this again.
Second good idea of today, by the way.
Yeah, that's it. You can stop working all week now. Talk about RAG for us, Brian.
Yeah. Okay. So RAG. So we talked about so far. I think we're kind of going through three main vectors, right? When we talk about the original, training pipeline, I think what they might be talking about is the data that gets done before or gets used like during the actual training process. Then we gave some fine tuning examples for we're modifying the model's behavior that actually gets cooked in during this fine tuning process using the reinforcement feedback or the examples like what Joff gave. But then we also have one other vector too, which is not necessarily going to permanently modify the behavior of the model in that it's not actually necessarily changing the weights or any of the intrinsic properties of the model. But what we are modifying potentially is the content that gets used as context when we ask the model a question, which is what happens in RAG, retrieval augmented generation, where we ask the model a specific question. It will go and it will look at the set of documents, files, whatever data that it has access to right now that might be up to date or domain specific, use those for context to then answer your question. So then if you can inject data into those documents or somehow get your own documents in there, information in there, then you are going to have an influence on the way that the model is going to, and the way in which the model answers questions or provides responses.
Right. Even though the model is just doing a contextually relevant vector-based lookup in the database, what comes back from the database, it just blindly trusts, right? It's not like the model checks it. It just delivers that data back. Yeah.
Yes,
Well,
exactly.
And this is the thing that I keep running again and again when I'm having conversations with normal people about AI. They're assuming that, well, yeah, there are.
Define normal.
Well,
I don't know
people who
anymore.
aren't in cybersecurity are one population, but there are others, and a lot of them they're still buying the marketing spiel that these AIs are actually intelligent, and I have to keep bringing it back. They're not. they have no discerning capabilities. They cannot tell right from wrong, good from bad, left from right. It's all dependent on the data. So that's why this data poisoning at whatever level it comes in is so potentially damaging, is because the model is going to assume that whatever it has is valid and it has no context in itself to choose good from bad, right from wrong. And that's why the human in the loop is so important, and why human in the loop can be abused.
Yep, 100% correct. And the phrase I like to use, and I'll throw it out again, and you know what it is, Bronwyn. We're dealing with LLMs that really are just simulated digital reasoning. That's what they're doing.
Get you a T-shirt with that made.
Yeah, I totally need a T-shirt
By
and
the
the
way,
bumper sticker.
OpenAI does list their GPT bot start crawling user agent. Just saying.
Nice.
I
All
figured
right,
they would
so
because, you know, there's
realistic
drama around the
threats.
crawling.
Yeah, yeah. Realistic threats, right? We've talked about these various things. Do we have examples? What's real, right? What can actually happen? I can think of a couple of examples that have been news stories. I know there's been some malicious Hugging Face models that have been pushed up there that you can just use, and they're advertised as really good to use for this purpose. But what else? What? How do we bring this to ground? What's real?
I know that in India, one of the things that they're looking at very hard is the fact that ChatGPT is very popular there, and their interactions are very, very deeply steeped in caste bias. So the responses that ChatGPT is giving are not allowing breaking down of the old traditional caste or caste. My pronunciation is herbal. And in terms of there are the elite castes, there are the untouchables, and all of that stuff is baked into ChatGPT. And modern people in India are trying to figure out how do we decondition ChatGPT and get away from that. Now, that may not be a deliberate attack, but it is a case of the bias and the data working against the populations that it's intended to serve.
Yeah.
Yeah, I mean, it goes back to the data preparation phase, right? Like when you're training a model that's going to be used, there have been entire books on this. Like, I can't remember the lady's name, but she wrote Weapons of Math Destruction. And she talks a lot about things that actually hurt people. And it was like, you know, large companies using hiring algorithms, right? And people getting cut out for whatever reason that wasn't, you know, fair to them. And so I think that these are things that are kind of intertwined. When you talk about specifically poisoning a model, yeah, that to me, if I were going to do that for realsies, aside from my honeypot idea, which maybe next year we'll say that's a real threat because now I'm kind of interested in that. But I think that if I were an actual threat actor trying to go after some kind of poisoning thing, I might target, especially for a general enterprise, I think RAG would be where I would try and go, like trying to, or some kind of like tool that the LLM is using to introduce new data, and trying to poison from that perspective. Because I think it'd be real hard from a training data perspective, at least for frontier models. Now,
well, if I were going after the training data side, just to be perfectly honest, I would probably take a needle in a haystack kind of approach, because it is true, or it appears apparent anyway, that there's not enough human cycles to examine every little bit of data that's going into training a model, right? I mean, that's
you're going to go start a Reddit with M's. Like,
yeah, that's as close to a fact as possible, right? I can see an AI business in examining training data alone, just on that basis. So what it means is we're coming back to statistical methods to identify outliers in training data, and that's imperfect by its very nature, right? We're not going to necessarily win. We're not going to have 100% granularity. That's just not going to be possible. So I think that rag and sort of a needle in the haystack in the training data is a potential here. It's a significant effort, in short, to be able to deal with this and to make sure your data's of quality. Dr. Furman, any other thoughts on that?
No, I think you guys pretty much nailed it in terms of realistic threats beyond, I mean, just a full either data compromise or supply chain compromise. I mean, outside of those approaches, I mean, that's, probably really realistically what we're looking at for what might actually happen and might actually have an impact.
Yeah. So what can we do about it? Defense in depth, right? I think this is an area that's not probably examined enough in organizations. Not only just perhaps the frontier models, they might be a little bit of a different classification because they're doing things at such a scale that they can probably afford the extra resources. But in the smaller, medium-sized organizations that are starting to train their own models and do their own things, which those things do exist, I think governance, provenance, and policy from a security perspective really matters here. Thoughts on that?
Yeah, certainly. I mean, if you've got, you spend the time up front to go through to curate your data, which in a lot of data science, that's where most of the time is spent, right? I mean, you spend most of the time prepping and not playing, we'll say, when it comes to the data science tasks usually. And so once you've gotten through that portion and you feel good with the set you've got, then it's important to make sure that you're keeping the integrity of that data, versioning it, as well as doing security assessments against your data storage, your data pipeline, and just kind of making sure that all those measures are in place to help keep the integrity of the data that you have once you know that it's good. Now, adding in new data, I mean, obviously you're going to have to rinse and repeat, right? Checking the data, curating it, going through that whole process.
Absolutely. Another aspect we really didn't even touch on either, because it's not necessarily topical, but it is related, and that is, model modification itself, weight manipulation and so forth, which can definitely have an impact here. Less about the data, though. That's more about model-centric attacks. All right, so let's have some takeaways. I think we've talked about this already. Data poisoning is not just a research demo. It is an actual practical thing that can be done and to manipulate AI systems. I think it's a larger threat to the more focused models that have specific tasks. And I think classifier models or time series analysis models, stuff that's not necessarily natural language processing, are definitely something that could be corrupted more than perhaps these large language models could be in this world. And I think a lot of that is because the frontier entities have kind of got the lock on the large language models right now. So, for the panel, if you could give like one rule of thumb to an organization that's thinking about deploying their own models, whether they be natural language processing or otherwise, what would it be?
Yeah, I mean, from the data perspective, just be careful where you're getting your data from, and be careful how you're storing it.
Yep. Bronwyn, Derek?
I would say treat all AI technologies as if they were still beta.
Good advice.
Treat them like drunk interns is what I tell people, because the current state of LLMs, they desperately want to maintain engagement, especially the frontier models. There's an assumption by, again, those mythical normal people that these tools are trustworthy and that they are accurate. I believe that when DeepSeek first came out, a lot of people in China were using it as an oracle. And, that's in itself is somewhat terrifying. Just always reality check. Yes, keep your data clean. Try and use discretion in choosing what data you're going to use, and double check it again and again and again. You want to make sure that the results that you're getting aren't drifting in an undesirable direction, and be very careful how you define desirable and undesirable.
So my bit of closing advice is this. I said this at the beginning, and I was joking around with the panel. Not everything is a nail. We have this phenomenon right now of everybody thinking they can use an LLM to solve the problem they're going to solve. Sometimes it is a case of square peg, round hole, and the LLM is not the best fit. Natural language processing is not always the right thing. And so from a data perspective, if you're in the business of training your own models, you might be, first of all, carefully consider the goals that you're going after. Maybe you need a classifier model or something simpler, and in that light, you can focus your data containment and data quality and data security efforts in that specific context. So don't forget, it's not all about LLMs. That's a part of my message just about all the time. So with that being said, I think we'll close it out for today. Thank you, panelists. Thank you, everybody, for listening to yet another episode of AI Security Ops, and hope you have a great day. Bye-bye.